6.1, and it's very short, and we're going to start 6.8. Okay, 6.1 is on radical functions, which are just the square root function. And remember what the square root function looks like. Just plain square root of x. If I put that in my y equals and table it, let's see what some of those points are just to get us the shape of a regular square root. Second square root x in my calculator. If I graph it, so remember, it's just going to go up and to the right. I'm going to put a couple of points on here. Okay, there's a point at 0, 0. There's a point at 1, 1. So to the right 1 and up 1. The next whole number point using good whole numbers is 4, 2. So 1, 2, 3, 4. Up 2. The next good whole number point is going to be at 9, 3. Okay, so that is what the square root function is going to look like on a graph. Okay, let's talk about the domain of square root functions. What has to be under here? What does it have to be in order to not get an I? It has to be positive, right? If you're not positive under a square root, you're going to get an I and you're not going to be able to plot it. There's not an I on the number line. It's not on the real number line. Okay, so the domain is always going to be what's under this square root is going to have to be greater than or equal to 0, right? That's what makes you positive, is if you're 0 or above. If you're below 0, what are you? You're negative. Okay, so it's always, your graph is always going to start by putting what's underneath here, greater than or equal to 0, isolate your x, that's where your square root function graph is going to start. Okay, so on number 1, it's just going to ask me what the domain of this radical function would be. The function is f of x equals the square root of 5x plus 8. Okay, so again, what's under your square root has to be positive. So what do I need to set up? What's under the radical, which is 5x plus 8. In order to be positive, that has to be greater than or equal to 0. Then solve it for x. Isolate your x, which means I would need to subtract 8 from both sides. So 5x needs to be greater than or equal to negative 8. And divide by 5. So your x values are going to have to be greater than or equal to negative 8/5. So this square root can start on the negative side, right? If this is going to start at negative 8/5, which is what? Almost. So in between -1 and -2 is where this one would start. You don't have to graph it. I'm just leading into the rest of the section. So that's where your graph is going to start, -8/5, which will be right about here. And still make the square root graph, okay? Because we're going to use because from here on out, it's going to ask me, it's going to give me a function, a square root function, and then it's going to give me 4 multiple choices to choose from of which graph is going to match it. And we're going to use the domain to help us choose which ones. The domain and our shifting rules. Okay, so number 2 says to graph the function f of x equals 3 times the square root of x. So what's the domain of this one? Where is it going to start? X it's going to start at the 0, right? X has to be greater than or equal to 0. This is going to make it steep. Another thing about this section is you're going to have to really pay attention to the scale that they're using, because on these graphs on number 2, the scale is actually going by 2s. Okay, if you put this in your y equals and graph it, it's going to look a little different unless you change the scale on your calculator. If I do, what do I can't, these all 4 options actually start at 0. So the domain doesn't help us on this particular one. Okay, but let's put this in our y equals 3 second square root x, and then graph it. So you'll notice it does start at 0, makes the square root shape. If I hit second table, let's plot some points. Let's see, there's a, let's plot some good points. There's a point, it starts at 0, 0. Now, if you did put this in your calculator, if you go, your x's go below 0, like -1, -2, you'll notice that the y that goes with it's going to say what? Error, right? Because the x's don't go negative. It starts here and goes that way only. So let's get another point. There's a point at 1, 3. So you just have to be careful because these are going by 2s. So 1, 3 would be over to the right 1, but it's not even to the first hash mark. 3. The next good point is at 4, 6. So 2, 4, 2, 4, 6. So the scale on this is just going to make it look a little different. It's going to make it look steeper just because of these are going by 2s, your calculator is going by 1s. Okay, so there are 2 that have this shape that look kind of like this. You're going to have to just look at where these points are and line them up with what I say, 1, 3, 4, 6. Okay. On number 3, this one is f of x is -2 square root of x. So what do you think this is going to do to this square root shape? It's going to flip it, right? Since the square root is negative, it's going to flip it upside down. It's still going to start at 0, 0, since that's just x. But it's going to flip on the other side. It's going to reflect across the x-axis. And it looks like these go by 2s also. So 0, 0, 1, -2, 4, -4. In your multiple choice, there's only actually one that has the square root reflected across the x-axis, like you want it to be. All right, number 4 is the exact same problem as number 2 was, so we're just going to skip it. If the only thing that would be different, like they're both a 3 right here, on that problem on MathLab, you may have a 4 or a 2. Okay, but it's going to be the same exact problem as number 2. Same way. Huh? 6.1. Number 5, graph the function f of x equals the square root of x minus 6. Okay, let's tie the domain to our shifting rules. What is this? It's an inside shift. So it's going to go to the right, correct? Because inside shifts are left or right, go opposite the sign. So this is going to shift it to the right 6. What's the domain? What's underneath here has to be positive or greater than or equal to 0. If I solve this for that x by adding 6 to both sides, what does x need to be? Greater than or equal to 6. That's the right shift. It's going to start at 6. Now, this one has a funny scale too. What is this one's scale? What are these hash marks going by? If that's 20, they're going by 5s. So when I shift it to the right 6, I'm just going a little past that first hash mark. You see what I'm saying? Because so it's going to look like it's just shifting a little more than 1, but since those hash marks are all 5, it's going to start here and go that way. There's only one in the multiple choice that has been shifted to the right. The other ones are shifted the other direction. But do you see the tie-in with our shifting rule? Our shifting rule told us that this square root graph was shifted to the right 6. And our domain says the x's have to be great. They're going to start at 6. Okay, so that's why the shifting rules match with that domain right there. Number 6. Graph the function f of x equals the square root of 2 plus 2x. Let's see what our domain is. 2 plus 2x needs to be greater than or equal to 0, so that it's positive. Solving for x, so I would subtract the 2's. So 2x is greater than or equal to negative 2. Divide by 2. So x is greater than or equal to negative 1. So this is where this square root is going to start, at negative 1. Okay, you'll be able to find that. Let's see what the scale is here. Looks like 2's. 2, 4, 6, 8, 10. I did not, what did I divide by? 2. When you divide by a negative, that's when it'll flip. And yes, you would do that. If you did have to divide by a negative, you would have flipped that. So where is this one starting? Negative 1. So there's its starting point. Okay, that'll actually be all you'll need to know to differentiate between the graphs. But let's graph it. Y equals second square root 2 plus 2x. Let's see. -1, 0. So there's where it starts. If you went to -2, you would see error. So let's go the other way. 1, 2. So to the right, 1, up, 2. And there's not another good one until 7, 4. So 2, 4, 6, 7, 4. To graph that one. So again, just knowing that it's a square root and it's starting at -1 is going to help you on that. All right, last one, g of x equals the square root of 8x minus 8. So my domain, 8x minus 8, needs to be positive or greater than or equal to 0. Solving it, so add the 8. So 8x greater than or equal to 8 and divide by 8. So again, x needs to be greater than or equal to 1. So once again, this one's going to start at 1. Oh, this one's going to have a really funny scale because 1, 2, 3, 4, 5. So the y's are going by 5s. And the x's are going by 2s. So it's just going to look different than what's in your calculator. It's just going to be steeper than what it looks like in your calculator. Okay? So it starts at 1, right? Now let's see. Let's get another point. Second square root. 8x minus 8. 8x minus 8. Table that. Let's see, there's a point at 3, 4. So these are going by 2. So there's 3. And then up 4. Which is, these are, oh no, wait. It threw me off. So these are going by 2. So 3 would be here. These are going by 1s. So it's going to look a lot steeper on the paper than it does in your calculator. Okay, so, but just knowing the domain is going to answer that for you in the multiple choice because there's only one square root graph that starts to the right one. Okay, all right, we are going to start 6.8. Okay, so going into 6.8, this is going to be on what's called piecewise functions and where they are increasing, decreasing, and constant, okay? Because some functions or some graphs is they don't have the same graph all the way from the left side of the x-axis to the right side of the x-axis. It changes depending on where your x is. Sometimes it'll be a line, then it can switch into a parabola, and then go constant, which just means go straight across, depending on where you are on the graph. So problems 1, 2, and 3 are how to locate where you are on the graph. Okay, here's what I mean. I'm looking at number 1. F of x equals, there's 3 different pieces. You're in x minus 1 for when x is less than -5. 3x for when -5 is less than or equal to x, which is less than 2, and you are an x squared graph for when x is greater than or equal to 2. It wants us to find what piece you would be in if your x is -3. What that means is we are finding f of -3. So let's put the deciding numbers on a number line. So the different numbers I see here are -5 and 2. There's my 3 different pieces. Think of that as the x-axis. What am I trying to find? F of -3. Where would -3 be on the number line? It'd be right there, right? Which is where? It's in that middle piece, right? This piece is less than -5, which would go to x minus 1. This piece, which is where my number is that I'm looking for, is in between -5 and 2, which means if I was going to plug it in, which we will get to that in a minute, I would plug it into the 3x piece. Right, number 2 is the same kind of problem. F of x equals 4x for when x is less than -5, x minus 8 for -5 is less than or equal to x, which is less than 3. So in between -5 and 3, and it's x squared for when x is greater than or equal to 3. So this time my numbers that separate the 3 pieces are -5, you're either below it, or you're between -5 and 3, or you're above 3. Those are the 3 pieces. It wants to know what piece f of 15 would be in. What part of this would 15 be in? Is it less than -5? Which means, is it over here? Is it between -5 and 3, or is it above 3? It's above 3, right? 15 is greater than 3, which puts it in the x squared piece. So again, you're just looking where this number falls. It's going to go into one of those. Since it's 15 would be down here, it's in that piece right there. Which means it would be part of the x squared group. All right, last, go ahead. That's what if it said this? Each number can only go in one piece. If it was f of 3, that's the only number that would be affected, because I see 3 here and here, but this says x is less than 3, which it's not. This says x is greater than or equal to 3, which it is, which puts this number in this group and not this one. So that's what that equal to, that the only ones that it matters is, like, what if it said -5? Is -5 less than -5? No. Is -5 less, or excuse me, let me read it this way. Do you see that equal to bar? X equals -5, which means it goes in this piece, not that piece. So the only time you have to worry about these equal to bars is if the number that you're looking for is one of those numbers. If it is one of those numbers, then you want to match it with the one that has the equal to bar. I think we may see that. Yes, we will. Number 3, f of x equals x minus 7 for when x is less than negative 2. 6x negative 2 less than or equal to x is less than 3, and x squared for x is greater than or equal to 3. And it wants me to find f of 3. So where does 3 fall in those pieces? Well, it's not less than negative 2. So I see this 3 here and here.
Would it be the second one because they're equal to?
Right, this one right here?
Mm-hmm.
Yes, because this number that equals 3. So that's the one, that's the kind where you think, okay, I need to go find equals 3, which puts it in what section? X squared. So now we're actually going to skip to number 10 because it just takes this one more step. You're going to find which piece this number goes in and then plug it into that piece. So that would mean I would replace this x with the 3. So it's just going to take it one more step. Okay, looking at number 10 is what we're skipping to. It's only got 2 pieces. G of x is x plus 9 when x is less than or equal to 3, and it's 6 minus x for when x is greater than 3. Wants me to find 3 different things. So for each one of these, I'm going to find that piece and then actually plug it into that piece. So let's see, negative 6. Is negative 6 less than or equal to 3? On this, is it on this side of the number line from 3? Yes. So what is that piece? Then plug in for the x with whatever's in it. So negative 6 plus 9, which gives me 3. What about 3? I see 3 is in both places, right? So what are you looking for? The equal to bar, right? This one has the equal to bar. So it's also x plus 9. And go ahead and plug in the 3 for the x. So 3 plus 9, which equals 12. 7 is greater than 3, which means it goes in this piece, which is 6 minus x. And replace that x with 7. So 6 minus 7, which gives me negative 1. Number 11. H of x equals negative 4x minus 9 for when x is less than negative 6. 5 for negative 6 is less than or equal to x, which is less than 5. And x plus 2 for when x is greater than or equal to 5. Negative 8. Which piece does it come in? Is negative 8 less than negative 6? Yeah. So it goes in negative 4x minus 9. Replace the x with negative 8.
That's 23.
Right, because what's this? That's
Positive.
right, 32 minus 9, which gives me 23. Let's see, where is 2? 2 is in between negative 6 and 5. So any number that's between that negative 6 and 5, the answer is just going to be 5. Right? There's not an x to plug it in. That's going to, you'll see when we start doing these next problems, that's just going to be a part of the graph that is constant, which means it's horizontal. H of 5. Let's see, 5's in 2 spots. Look for your equal to bar, which means it goes in x plus 2, which is 5 plus 2, which gives me 7. And 8 also goes here, right? Because 8's greater than 5. So it also goes into x plus 2, which plug it in, 8 plus 2, which gives me 10. Now let's go back to number 4. So we're going to see what a piecewise would look like on a graph, where there's just different things happening depending on what your x is. Now number 4. Yeah, I just wanted to do those last two, 10 and 11, because they obviously just piggyback right after those first 3. Just takes it one more step. Okay, so this doesn't try to confuse us with scale. It's going by 1. So this number line goes forever to negative infinity. That side goes to positive infinity. Let's see what this graph looks like. All right, so it's got 3 different pieces, right? That's doing one thing. That's doing another. That's doing another. So let's talk where these questions are all going to be concerning what intervals you're increasing, decreasing, or constant. So what are the y values doing? What are the values doing here? Decreasing. So this is a decrease. What's happening here? Constant. Remember that one on that last problem? Where if you were between whatever those numbers were, -2 and 5, you were just 5? That's what that looks like on a graph. So between -3 and +3, all the y values are exactly the same, right? Because they're all constant. It's constant. What's happening here? That's an increase. So what I like to do first is go label what's happening on each part of the graph, then go through at the changes of directions and label what their x coordinate is. Because remember on Monday when we were talking about increasing and decreasing, we in the interval notation stuff, we use the x coordinates. That's what changes. That's what depends on where you are, left or right, what your change in direction is. So I like to do my change of direction points. So it's doing one thing here. Here's my change, right? What is its x? -3. I like to put that there so when I do my interval notation, I don't even think about the y's. Okay, what is this one? Here's my next change of directions. What's its x? +3. Because now the questions are, the function is increasing on what interval? Let's see, decrease, constant. Here's where it starts to increase, which is 3 to where? Infinity. So that's your increase interval. 3 to infinity. Change of directions, always use parentheses, right? Because it's not increasing at 3. It starts right after the 3, right? It's not doing either one of those at 3. It's the change. Let's see, the next thing says the function is constant on what interval? Here's my constant. Where does it start being constant? -3 to 3. And the last one's going to say, where is the decreasing interval? Where does it start decreasing? Until it gets to -3. So that's why, even though it takes a little bit of work on the front end, but I really think labeling each piece on what's happening there, decrease, increase, or constant, and also writing out what the x coordinate is at the change of directions, because then once it asks you increase, constant, and decrease, it's literally sitting right there in front of you. Also, I think labeling the x's helps so that you don't ever think about the y coordinate at those points. Okay, let's look at number 5. We're going to do 5 and 6 and then finish the rest on Friday. Okay, let's see what's happening on the different pieces. Let's see, I am constant here. I'm increasing here. Going down, so decreasing here. And increasing again. Now I'm going to go through and label the X coordinates. Okay, now remember, yours is going to be exact, right? I'm freehanding this. This one's X is lined up with -9. This one's X is -5. This one's X is also -5. This one's X is 2. That one's 3. That one's 5. And that one's 8. All right. Increase, decrease, and constant. Where is it increasing? There's actually 2 intervals, right? This is why I think it's very beneficial to just go through and label all your X's. What is the first interval that it's increasing? This one right here, which is from where? -5 to 2. And the other increase is from where? 5 to 8. Decreasing. Here's my only decrease. It's from 3 to 5. Right. The constant is this piece, which is -9 to -5. And 6, which is going to be the last one that we'll do today. All right, I'm going to label my X's, or actually I'll do my increase, decrease. So what's happening on this piece? Increase. So it gets here, then it decreases. Here it's constant. Another increase. another constant. I label my x's. That one is -7, -5, -2, and -1. So do your increase, decrease. And constant. And I'll take a little bit. So the increase starts at -infinity to -7. Put a comma in between. Here's your next increase, -2 to -1. Where is the decrease? Now this part right here, right? -7 to -5. And what about the constant? -5, -2, comma, there's another constant, 1 to what? Infinity. All right, so we will wrap that up next class.